Alright, so we're going to identify linear functions today. Your learning target is I can identify linear functions given a graph, a table, or in an equation in standard form. So first thing we're going to do is we're going to define what a linear function is. And it's a function whose graph is a straight line. Okay, so there's no curves to it. It's from one direction to the next. It is a straight line. As well as it's a function, which means that it has to pass the vertical line test. That means it cannot be a vertical line. It has to be at diagonal or horizontal at some point. So every x has to have one corresponding y. So for example 1 here, it asks us to first identify whether each graph represents a function and explain that, which we did last unit, so we know how to do that. And then it says if the graph does represent a function, is it linear? Okay, so that's what we're going to do here. This first one, we can see that the graph, if it passes the vertical line test. So to answer that first question, yes, this is a function. Because it passes the vertical line test, I'm going to put VLT for vertical line test. Okay, and then is it linear? Well, we can just tell by this graph here, it's a straight line, so therefore it is also linear. It's a straight line. And a straight line means that it goes up by the same amount for every x and every y. Okay. Now this second function here, we can see that yes, this is also going to pass the vertical line test, so it is a function. It passes the vertical line test, VLT. But is it a straight line? Is it linear? We can see that no, there's this curve to it, so no. This is not going to be a linear function because it is not a straight line. Not a straight line. And then this last one here, we can see it's a vertical line here, and therefore this is not a function at all because it does not pass the vertical line test. Vertical line test. Okay? So back when we were trying to identify functions, we knew that if every single one of the x's was different in a function table, if we built a table and every single one of those x's were different, then we had a function. A linear function means that it has to go up by the same amount, the same rate of change for every x and every y. Both the x's and the y's have to go up by the same amount. So if we're given this table right here, let's put that in, or these coordinates here, let's put that into a table. So if x is 0, then y is -3. X is 4, y is 0. 8, 3, 12, 6, and 16, 9. Okay, and then we want to evaluate what is happening here. Well, we can see that from 0 to 4, it goes up 4. It goes up 4 between 4 and 8, up 4 between 8 and 12, up 4 between 12 and 16. Okay, so we can see how it's going up here. For y, it's going up 3, up 3, up 3, up 3. And so because it is the same rate of change, the rate of change being 4 over 3, because it is the same rate of change, then this means that it is a linear function. So yes, each x and y goes up by the same amount. Each time. Okay? That makes it a function. Now if we look at b here, and I'm going to move this down a little bit, b is going to be a little bit different. We've got again, needing to build a table. So -4, 13, -2, 1, 0, -3, 2, 1, and 4, 13. We see that it goes up to every single x, which means that this is a function. Okay? But if we look at our y's, it goes down 12, down 4, up 4, up 12. We can see by this, because it is not the same, that this is not going to be a linear function. So it is a function, Every x is different and it corresponds with a different y. However, it is not a linear function, okay? No, because y is not a constant rate of change. And that means that it cannot be a linear function. So we're going to talk about the standard form of a linear equation now. And the standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers and a and b are not 0. Okay, so a, b, and c can be any real number except a and b cannot be 0. So in order to be considered linear, there's certain requirements that an equation needs to have. Okay, for example, the first thing, x and y both have to have an exponent of 1. They have to have exponents of 1. So that means that you can't have x squared or x cubed or x to the negative 2. It has to be just x and just y. There can't be some exponent to some number. The second little dash here is x and y are not multiplied together. Okay, if this is going to be linear, we cannot have x being multiplied by y. And then finally, the last one here is that x and y they cannot appear in denominators, exponents, or radical signs. Okay, radical signs are those square roots. So they have to be just in its most simple, basic form. Okay, so some examples of linear would be like 3x plus 2y equals 10. That is standard form right there. Y minus 2 equals 3x, or negative y equals 5x. Those are all examples of linear equations. Nonlinear would be like 3 times x times y plus x equals 1, because x and y are being multiplied together. It couldn't be x cubed plus y equals negative 1, because x is not an exponent of 1. It couldn't be x plus 6 divided by y equals 12, because y is in the denominator. Okay, these are all reasons why a certain thing could not or could be linear. So for example 3, we're going to tell whether each function is linear, and if it is, then we're going to graph that function. Okay, so first off, we've got x equals 2y plus 4, and so let's go through those 3 little bullet points that we had to make sure that this is linear. The first thing is x and y both have to have exponents of 1, and we see x and y both have exponents of 1. They cannot be multiplied together. They're not being multiplied together. And they do not appear in the denominators, exponents, or radical signs. And we see that that is true. Therefore, this is a linear function. Okay. So let's go ahead and graph this real quick. And anytime you're trying to graph something that isn't necessarily in the most perfect form, a good idea would be to solve for y first. Okay. So let's go ahead and do that. We're going to subtract 4 from both sides, and we're going to get x minus 4 equals 2y, and then divide by 2, and we'll get x minus 4 divided by 2 is equal to y. Alright, now we have an equation that we can work with, and we just plug numbers in for y to be able to see, or sorry, plug numbers in for x to be able to see what y is. Okay, so let's go ahead and start with 0. If x is 0, 0 minus 4 is negative 4, and negative 4 divided by 2 is negative 2. Which means that we're at this little point here on the graph. Let's go ahead and try 2, okay, x being 2. 2 minus 4 is negative 2. Negative 2 divided by 2 is negative 1. Means we're going to be at this point right here. And we'll try 4 as well. 4 minus 4 is 0. 0 divided by 2 is just 0, which means that if x is 4, y has to be 0. And we can see that what we're creating here is this line that looks like it's on its way down, right? Remember, we want to try at least 5 numbers, so let's try 2 positive, 2 negative, and 0. So let's go ahead and try negative 2 now. Negative 2 minus 4 is negative 6. Negative 6 divided by 2 is negative 3. So that means we're going to be at negative 3 here. And we'll try negative 4, 2. Negative 4 minus 4 is negative 8. Negative 8 divided by 2 is negative 4. And that means that this is going to be at this location right here. So what we have here is a graph that looks something like this. Okay, and that's what you're supposed to do for that kind of an example. Now for B, we first need to remember to find out, is this a linear function? And we've got x times y, and we see that x times y, that that is against what our second statement was up above. X and y cannot be multiplied in order to be linear. And so what we have to write here is that this is not linear. It's not going to be linear. Okay, that's all we're doing today. Hope you enjoyed.